Hello. Now we'll study how we will calculate the capacitance. So you see, majority of cases, the examiner will be giving you two bodies of different structure, obviously. And generally, examiner will give you symmetric structures. So A and B, the two bodies will be given. And he will ask you the capacitance of these two bodies. So to calculate the capacitance of the system, including A and B, what we will do, we'll start with a atom, that's a neutral charge. And we will segregate that neutral charge, so we'll be having one plus charge and one negative charge. So that plus charge I'll place on one body and the negative charge I'll place onto the other body. So now see, if you add these two bodies, the net charge is still 0. So by putting the plus charge here and by putting the negative charge here, you have not changed anything. So you are segregating the charge, and this segregation of charge is creating the potential difference. And obviously in this whole universe, A, B plus outside, if you see, the maximum negative charge is onto the body B, and the maximum positive charge you can see onto the body A. We always assume this is a segregated system. So the body which is holding the maximum positive charge, obviously this will be at the highest potential. This will be highest. This will be having the highest potential. Highest potential. And the body which is having the highest negative charge will be having the least potential. So by segregating these two charges, plus Q and minus Q, you have created the potential difference. Here it is VA and here it is VB. And we all know this potential difference is being created because of these charged particles. So what we will do, we will calculate VA. Obviously, VA we will calculate by using the Coulomb's law and other formulas, and then we will calculate VB. And when we will calculate VA and VB, we'll take the difference, because ultimately the difference is defined as V. So when we will take the difference between VA and VB, we'll be getting some value. And obviously when we will be calculating VA as well as VB, that value will be a function of Q. Here also it will be a function of Q. Some Q will be coming there. Okay. So when you will be having B, when you will calculate VA minus VB, that is VB we are defining, that will come out to be proportional to Q, and that some constant will be there. So when you will calculate the V, which is VA minus VB, that will be Q times something. Okay. So we all know the formula for C. Since C is Q by V. So what we will do when we will calculate this thing, from here, we'll take the ratio of Q by V, and that value, whatever value will be remaining there, that we will define as capacitance. So that is a general method of calculating the capacitance till we make the formulas actually. So that's how we make the formulas as well. So whenever the system will be provided to you, obviously two bodies, you will place one positive charge onto one body and another negative charge onto the another body. The magnitude has to be same. And by doing so, you have created the highest potential as well as the lowest potential. You will calculate potential here because of all the structure. Obviously, when you will be calculating the potential at A as well as B, you have to take into account. Both the bodies you have to take into account using the Coulomb's law. Then you will calculate the potential at B, accounting for both bodies. When you will take the difference, that will define as V, and that value will depend upon Q times of something. So from there you will take Q by V ratio, and whatever something will be remaining, that value will be defined as the capacitance for this whole system. Okay, and that capacitance will be independent of the value of Q. It will be independent of the value Q. It will not depend upon that. That capacitance will only depend upon the dimension of this system as well as the medium in between. Okay, so that's how you calculate the capacitance for any system. Now one more thing, many a time what happens, the examiner gives you only a single body. So he'll only give you A. B he will not give you. So in that case what we do, if A is only given, in that case B you send at infinity. You assume that B body, which is exactly similar to the A, is placed at the infinity. And you place positive charge here, and the negative charge will be going at the infinity. But by sending this B at the infinity, when you calculate VA, when you calculate VA, the effect of B onto the A will be 0, because that B is at the infinity. And potential at the infinity we always assume 0. So the moment you send this B to the infinity, at the same time you can assume the potential of B becomes 0. You can put the value there. Okay. So if the single body is given, You put a symmetrical body at the infinity and you assume the potential of that symmetrical body to be 0. And the plus charge or the negative, it's up to you. I always go by the positive charge. The plus charge you will place at body A and the negative you will place at body B. When you place the negative charge onto the body B, potential will remain 0. And then you will calculate the potential of body A. And that potential will be defined as V, because VB becomes 0. So whatever is the potential of A, that is your V. And from there you will calculate the ratio of Q by V. So when you will do that, you will get the capacitance, and that capacitance will be the capacitance of the whole system. This and the other system which is at the infinity, which generally we don't talk about. Okay, so it's not like whenever we calculate capacitance, capacitance is always calculated between two bodies, not for one. So if only one is provided, the second one you will place at the infinity. Okay, so that's how we calculate the capacitance. I hope you understood that. Now we'll do some examples of that. Okay, thank you.